Hey guys, what is up? What is up? So we're even though we didn't really have a chance to go over some of these problems today from the AP practice test chapter 7, I'll go over one right now. All right, let's go and take a look right here. Okay, so here is the problem. It is the following right here. Oh, I closed it out. Oh, shoot. Okay, folks, I am back. All right. So number 13. According to government data, 22% of American children under the age of 6 live in households with incomes less than the official poverty level. A study of learning in early childhood chooses a simple random sample of 300 children from one state and finds that the sample proportion, p hat, equals 0.29. Find the probability that at least 29% of the sample are from poverty level households, assuming that 22% of all children under the age of 6 in the state live in poverty level households. Okay, so let's take a look right here. So this is, of course, number 13. All right, so we said that right here, we're going to assume that right here that the population probability is 0.22, or population proportion, you can say. Okay? And we want to try to find the probability right here that at least 29% of the sample are from poverty level households. All right, so right here that we want p hat, so in the probability that p hat is greater than 0.29. Okay, so no problem. So what we're going to say is, first of all, we know the mean of the sample proportion. The mean of the sample proportion distribution is just going to equal, as an unbiased estimator of the population proportion, which we already said is 0.22. Done. All right, also now to get the standard deviation of the sample proportion, what we're going to do is first we'll show the 10% rule for independence. So that's going to say what right here? That we have n equals right here, said simple random sample of 300, right? N equals 300. So we're going to ask the question, is n equals 300 less than 10% of, right here, what are we talking about? Children under the age of 6. Okay. So we're talking about 10% of children under the age of 6. All right. So because of this, now we can get the standard deviation of the sample proportion. So of course, that's a formula right there. That's going to be the square root of p times 1 minus p over n. That's going to equal the square root of 0.22 times 1 minus 0.22, which is going to be 0.78, all over n, which once again is 300. So when we calculate this all out, we're going to get 0.0239. Oh, happy day right there. All right, chunk, 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 chunk. Okay, so very good. All right, let me move the operation up a little bit. No problem. So now we can actually calculate this probability right here of, remember what we're trying to find. We're finding the probability that the sample proportion is greater than 0.29, okay? All right. Next thing, right, by the way, one thing that I didn't actually bring up at all, and this is for number 13, why can we assume that, by the way, it is normal? Because it didn't say in the problem that the population distribution was normal. So how do we know right here? Well, last thing right here is that, first of all, we want to say, we want to ask, is it approximately normal? Okay, so we have NP has to be greater than or equal to 10. And also at the same time, we have to find out that, that n times 1 minus p has to be greater than or equal to 10, has to be at least 10. All right, n is once again 300, p is 0.22. All right, and that right there is 66, which is greater than or equal to 10. We get a different color here, sorry about that, check. And then we'll say, we know that n times 1 minus p, so 300 times 0.78 is going to be 234. That's also greater than or equal to 10, check. All right, so we can say that the sampling distribution of p hat is approximately normal. Oops, sorry. Okay, so going back to where I was right here, let's go ahead and draw our normal distribution curve. All right, so we already said that, once again, the mean was, once again, if you go way up here, 0.22, right? Our standard deviation was, once again, right here, what was it? It was 0.0239. And actually, let's make sure we use the correct terminology right there. Remember, it was the standard deviation of the sample proportion, okay? And this was, again, the mean of the sample proportion. All right, so we'll make 1 to the right, and 1 to the left. If I add 0.0239 to this, I'm going to go ahead and get right here 0.2439. And if I subtract 0.0239, I'm going to get 0.1969, it looks like. Okay, no problem. And we're trying to find out greater than 0.29. So let me use a different color right there. So that would be all the way up here, right? All right, so right here we're talking about p hat. Right here is equal to, right here, 0.29. All right, so just that little corner right there. All right, so what are we going to do? The same thing we always do with normal CDF, right? We'll say normal CDF, lower, it's going to be 0.29, upper, 10,000, mean is right there, 0.22. Standard deviation is going to be 0.0239. Okay. And you should get for your answer right here 0.0017. Very, very, very small probability. All right, so very small chance looks like of this actually happening. Given your original figure of 22% of American children under the age of 6, the chances of this sample proportion of 0.29 or greater happening is 0.0017, given your original figure of 22% of American children under the age of 6 live in households with incomes less than the poverty level. All right, so very small. Let's look at B. All right, B says what? Let's go back here. Based on your answer in part A, is there convincing evidence that the percentage of children under the age of 6 living in households with incomes less than the official poverty level in the state is greater than the national average of 22%? Explain your reasoning. Okay, so remember what I'm always saying in class, when the p-value, this is essentially your p-value right here, what we got right here. And that is very, very low. When it's extremely low, all right, that is giving us evidence. So yes, this actually is plenty of evidence that right here, that our actual population probability should be higher. Okay, so I'm answering that properly right here in context. Because the probability of getting a p hat value of 0.29 or greater is extremely low, 0.0239, there is convincing evidence that the percentage of children under 6 living in households under the poverty level is actually greater than 22%. So let me just write that down actually for you instead of just reading it out right here. Let's do a different color here to add a little variety. All right. So we're going to say right here, because the probability of getting a sample proportion p hat of 0.29 or greater is extremely low, and then right here, and I'm just going to say what it was, 0.0239, or you could say even 2.39%. That would be fine right here. All right, and I'm going to reference right now, I'm going to say given the 22% population proportion, we have evidence, there is significant evidence that the percentage of children living under the poverty line, oops, sorry, is greater than 22%. All right, good enough. Actually, that's probably a little too much right here. So because the probability of getting a sample proportion p hat of 0.29 or greater is extremely low, 0.0239, given the 22% population proportion, there is significant evidence that the percentage of children living under the poverty line is actually greater than 22%. Okay? Good enough right there. Okay, not too bad. Just remember, when you have a p-value, essentially what we found was a p-value, right, of something so low, that is giving us evidence, okay, that the original population proportion is off, right?